Okay. Today I have a video that could be interesting for all of you. Welcome to another Solana tutorial. Today we're gonna talk about getting longer vanity addresses for your programs and tokens. So this is something for the devs who just want to get their own token with a nice vanity address, and the real devs who want to deploy proper Solana programs. Both of those things, tokens and programs on Solana, live on an account which has an address, which we call the token mint or the program ID respectively. And there is no real use for having a nice address, except for it looks nice and it's something that you can show off with. Like if you have a token where the token name is the first 7 letters, that's pretty impressive. Same with the programs. Native programs exempt because there it's easy. But if we look at the token program, hold on, let's do that. Token keg has the following address. Token. So that's 5 letters, which is pretty impressive. They probably grinded quite some time to get a private key where their associated public key starts with token. So what they did is get a random private key, derive their associated public key on the ED 255 something something. What is it called? 25519. So elliptic curve cryptography. Then they base 58 encoded that public key, because first it's just 32 bytes, then they base 58 encoded that, and then they compared the string if it starts with token. So we have those 4 operations. First one, getting some random values, that's cheap. The second one, getting the public key from that curve, that's expensive. So that's what we want to get rid of. And then we still have the base 58 encoding, which is semi-expensive, but can be optimized by using different libraries. And then string comparison is cheap again. That's literally just check the characters and, that's O out of N and that's cheap. I've already hinted in the previous video that this is what we're going to do. And once again, I need to give a shout out to Mr. cavemanloverboy, Dr. KV PhD, who basically inspired this video series. Because that just seems like fun. Yeah, so as we said, the curve arithmetic, that's the most expensive. That's what we want to get rid of. And then this is what we want to optimize. He has a repository. There it is. He has a repository where he does that. But we're not going to start with this one yet. We first want to build our own inefficient version just for our understanding how it works. Because if I start with that right away, then you don't really know what I'm doing. So we're going to go through that step by step. And then at the end of it, you hopefully are able to create your own vanity address for your token mint or program ID. That is, longer than usual. What is usual? Quickly, I can get 4 characters if I start with capital A to H. Made a video on base 58 encoding if you want to know why. And 3 characters in any other case. That's quick. Within a decent time, you also get 4 characters. And if you're lucky, you might as well get 5 characters like, token. But that's pretty much the limit then. For 5 characters, you will already have to wait quite some time or have a really, really powerful machine or like GPUs for grinding. Oh, and if you don't know what grinding means, that's when we say Solana keygen grind and we specify what address it should start with. So again, 4 letters is possible, takes a bit. Let's see how quickly I can grind myself an Andy address. Oh, I was very lucky. This time it takes a bit longer. There we go. So we had to search through 5 million key pairs to find me that Andy address. And we could do that in my current system in like 12 seconds. I am recording as well, so it would be a bit faster if I wasn't. But still, that's approximately the time it takes. So that's something realistic that I'm used to, right? And now, what do I promise? That with our trick, I will promise that we get 5 characters relatively quickly like this. And I would assume that we would get up to 6 characters relatively quickly. But I won't promise that one. We will see though. According to Caveman, in his tests there, it's quite a speed up. He got like length 7 within several minutes. And I don't know if that's with CPUs or GPUs. I think that's with CPU still. And then with GPUs, you can be a lot faster. But I don't have a GPU, so we're not going to do that either. You can play around with that yourself as well. Just clone this, try it out, like we will today. But before, let's reiterate, what was this trick? As I said, we have those 4 steps. And we want to get rid of the expensive one, which is the curve arithmetic. So we don't want to get from private key to public key. We would just like to have the public key. And the trick is to do it with a system program create account with seeds. Then there is no private key, or well, at least we don't need to know it, because all that is a SHA-256 hash. And hashing a bunch of things together is way cheaper than this curve arithmetic. So we need to do another step, but that is cheaper than the thing we replaced, so it pays off. And I already showed you, where did I have that? So this is how we did it for a program. If you do it for a token, you want your token kek or the token z in here. And basically, with a system program, if we create with seed, then we put in the base address. So this is the guy who's then able to sign for that account, or who has the authority to let the system program know that it can use that account. The program address, that must then be the matching owner of the account itself. So the account itself will be put to that owner, because there's a system program create account that assigns the account to a program as well. And then the seed. And the seed, that is the thing that allows you to have several of those accounts with the same authority and owner, by just putting a different seed. And that is what we are gonna change in order to get different addresses. Because if we have a constant seed, then it will of course always be the same account, which in our case is this 47WKX. And no matter how often I run this, this will always be the same account because it's deterministically derived. But as soon as I change the seed, I change the account. And then I just need to do this iteratively until I get an address that starts with the letters that I want it to start with. Or I could search for something in the end, or even somewhere in the middle. You know, it's up to me how I do my string comparison. But yeah, in the easiest case, usually people search for something in the beginning of the address. So let's do a simple, inefficient TypeScript implementation of this and see how efficiently we could grind addresses like that, just to have a reference. And there I would assume that we're similarly efficient than the Solana keychain grind, possibly even less so, but we will see. And I'm gonna make it super easy for myself, just a very high level. I'm gonna use all of the JavaScript implementations, do the same thing as here, just that I will now change the seed. And because I'm a lazy person, I'm just gonna do like do a number and then a forever loop. It's called an infinite loop, Andy. And my seed or program plus that number, which is inefficient because string concatenation and whatever. And I'm gonna use their implementation. Behind that, there's a SHA-256. We can look at how that is actually, well, actually not, no, we can't because I don't have the code. We could look at how that's actually derived, and we will look at that later. But for now, we just say, okay, we treat that as a black box, which again is a bit inefficient, but it's fine. And then it's literally just a, if my address to string starts with whatever I want it to start with, let's say Andy, we log the seed. Sorry, I'm not in Rust. I'm just not used to that anymore. There we go. Good. Then I want some kind of print, you know, every, let's say, how often did you do it here? Every million. Okay. We log something similar. We didn't try key pairs, but we tried seeds. Okay, let's see how fast that would go without any optimizations. That is not good because what I forgot, of course, is to also increase that variable. So yeah, so that is taking definitely longer than the grind implementation of Solana Keygen, like way longer, way longer. But yeah, we are also not being efficient at any place in this program whatsoever. Okay, I want to see how fast it is. Let's print every 10K. That's approximately how fast it is, which, you know, is not fast at all. But again, TypeScript plus inefficient implementations. But just to prove that we can do something with that, let's try and get an address that starts with AN at least. That's relatively fast. There we go. We just need 1,000 if I want 3 characters. Should also get that relatively quickly, 3K. But yeah, you see, obviously it's always the same because we don't have a new random. It's not random, it's literally an I here. So yeah, that running that again doesn't change anything, of course. So I would need to either add something to the seed or do a new random. I concatenate this in front or whatever. Then it changes. So let's see how many we need to grind through to get 3 letters this time. And again, this is not very efficient. There we go, 8K seeds. And we had a random number in front. But if I run it again now, then it's again quicker. So this way we find seeds where 3 characters match in the beginning and DOI. And if I wanted to have this particular address for my program, then we do the thing that we did last time, but with this seed. Remember in the last video how we changed the CLI for the program deploy to take a seed as well? And where did we put that seed? There. We just hard-coded it in there. I could have, of course, have the CLI take it as a parameter. But if I now put that particular seed in there, then I could deploy my program to that address that we just found here. Let me prove that to you in that directory where I have the deployable program with my CLI, and I paste in that program ID because it needs to match with the seeds. That did not work. Hold on. Oh, I know why. Because I didn't build it. That's why. Because if you hard code the seed in here, you also need to rebuild that stuff. But maybe that's a good exercise to try this with the Solana keychain recover. So we recover. Then I want you to write it to a temp JSON. This is the seed phrase. I just pasted that thing. It does not have any passphrase. I guess that's the right thing. So I need to say yes. That's something that I did wrong a few times. And then I was like, why don't you export it? Because you need to say yes here. And then we have the recovered key pair here in the temp. So that's the buffer account essentially, because we don't have enough money in there, but Solana balance of this recovered thing there is the 1.5 sol now. So when I deploy again like this, I can now, as it already hints here, add the buffer signer. Buffer. There, dash buffer. Buffer is this temp JSON. Boom. And now this will work. Nice. Very nice. Oh yeah, we said it prints the wrong thing here. Forget that. But anyway, the program was deployed to this address. This is now my program. See, it's a program account. And UI. So that stuff works. This is how you do it for program accounts. I will show you later how to do it for tokens, but it's actually even simpler for tokens than it is for programs. So it doesn't get a separate video. We will do it here later. First, we need to get a proper address that starts with, more letters than 3. So I'm gonna ditch my inefficient implementation from here right away and try and get this one to work, because it's blazing fast. 1 billion addresses per second. Wow. That's a bit faster than what I could manage so far, because he has external libraries that are more efficient. The fire dancer implementation. Nice. Okay, cool. Yeah, let's clone that. And we're gonna open it. Should we go through source code? No, we first try if it works out of the box, then we're gonna analyze it. So out of the box, README says cargo install Vanity. There we go, installing some dependencies. The SHA-2, there we go. Interesting, so it's at cargo bin Vanity. Cool, so we have it as an executable Vanity. Nice. So let's use that. Let's see if it's intuitive enough. Base owner target. Base and owner makes sense. Target. Okay, maybe I'll open the help. Target. The target prefix for the pub key. Oh yeah, that makes sense because I want to search for something. That's true. So true. Okay, so let's just do it. Base will be my authority. Owner will be the BPF loader because I want the program address. And my target is Andy. Let's see how fast that is. Fast! Damn! What the? Look at that. It took 16K and in 0.02 seconds, because that's about 700,000 attempts per second. Well, that is more efficient than what I managed to do. Caveman Loverboy, that's a nice grinder that you got there. I like it. So can I do NDS to increase the heat? 20 threads. So here we already need to wait. So it's not immediate, but it managed within 20 seconds and, 38 million attempts. And to get to 38 million with this kind of a grinder would have taken longer, right? So we had like 5 in 12 seconds, 5 in 12 seconds. So less than 10 in 20 versus this one who got to 38 in 20. So it's not quite an order of magnitude, but it is faster. It might be one order of magnitude, like twice as fast. Cool though. But how do I use this now? Did you print the actual seed? That's the target. That's the seed. Is that the seed? So let's actually look at the source code, what that thing does. So the seed, the seed is a U8 16-byte array. That's alphanumeric. So it's not that complicated of a code, and it's just that file. It's really not that difficult what he does. Let's go through it. Keeps track of time. The first thing is the seed that it gets from a random number generator. Then it builds this SHA-256, which it initializes here and already puts the first one, the base, into that one, that it just needs to then clone this one, because it's always first the base. The way this key is derived, the way this works, this create address with seeds, it's just a hash from base pub key bytes, the seed bytes, the owner bytes. Wasn't there something for PDAs? No, because we're not building a PDA per se, we're building this create seeds. Yeah, so it's just those three. And since the base is always the same, the owner is also always the same, but there's the seed in front. So in this chain, we need to put the seed first. So that's why we can clone the base first and then add the seed and the owner. And we actually build that SHA and get the bytes out and then get the pub key as a string with the base 58 encoding. So that's step 3. Yeah, and then we just do a string compare here. If it starts with that, that's cheap. Yeah, and then we do the logging for it. Okay, can we do the logging in a way that I have to seed as a string? From UTF-8, let's do from UTF-8 to vector. And I don't care if I'm inefficient here, because this is just logged once it actually found the seed. So I'm okay with being inefficient. And that will give me a result. And I will just assume that it works. So I'll unwrap this. And then I have the string. Cool. Try the same thing with NDS. Boom. Boom. There we go. 5 seconds. Wow. And it did not take this at all. Hold on. What's going wrong here? Target debug Vanity. Wow, my computer is running hot. Yeah, it's a perfect day for that because it's like 33 degrees centigrade outside. And in here, probably also 28 or something. Hot, way too hot. Oh wow, this time it's taking longer. This time it's not so lucky with the random generation. Oh no, not that it's unlucky. I have a dev build. That's stupid, hold on. If anything, we should build that in release. We don't want any dev stuff in there because we're trying to run something efficient. Compiler, throw out as many things as you can throw out. In release, hopefully this is faster now. Yeah, faster, way faster. I mean, maybe also more lucky, but yeah. We found the target, NDS, PRG, and that is the seed. Wonderful. So, if I take that seed and plug it into my CLI, okay, at some point I'm gonna, you know what, I'm gonna make I need to make an argument for this. This is getting annoying. Here I wanna have it. I will force you to have a seed, otherwise I just die, that's fine. You know what? I'm not using the tests. Let them go die. So, okay, does it build? Okay, great. I hope that I made it in a way now, we don't need that anymore, that I can say seed, put in the thing that we found, alongside the correct program ID, of course. Let's see. No, seed wasn't expected. The seed, yo. I'm not writing a nice program, I just want to have a working program. Build again. Now looking better, look. Boom. We deployed our program to NDS program. Nice. That's a nice program address. NDS program. So I can say that was like 8 characters, right? Because the PRG was totally on purpose. No, it's not. But 5 I managed relatively efficiently. I would also manage 6. How long would it take for 6? Let's say, okay, that's 5, but starting with a P. So that's more difficult. That will also probably take a few seconds. Well, yeah, running hot, huh? That's definitely more difficult because essentially we're searching for one more letter. We're not starting with A to H. There we go, but we found one after 2 minutes with 166 million attempts, and that would be the seed for it. And we could deploy a program to this address now, even though we cannot sign for this, but we know the seed that in combination with our authority and this owner, the system program will allow to create this account. That's pretty cool. 5 letters, that's what I promised. 6, if you start with A to H, it should go in 1 or 2 minutes. If you start with anything else, then you might need to wait longer. But 6, definitely also possible. And we're still not even using GPUs. So yeah, that's a pretty cool implementation that cavemanloverboy built for us here. I like it. And yeah, the trick is using a good base 58 library. Cool. As a last thing, because I promised, I'm going to show you how to now use such an address as a vanity address for your token. Because I know that you want to create a token that starts with your freaking 10 letters. 10 is probably too much, but you might manage 7 if you're doing it right. So let's do that. Start by finding the seed. Again, even you as a dev, aka script kiddie, manage to run this because it's literally just clone it, install it, run it with the right parameters. You will manage that. And essentially it's almost all the same, except now the owner will not be the BPF loader upgradable, but our beloved token program, this one. So we do the token program and then target. Again, here you can put your token name or whatever you want it to start with. So let's do token, why not? 1, 2, 3, 4, 5. That is a lot. So it will again need like 2 minutes or so in that ballpark. But I'm gonna let it grind with 20 threads for some time to get myself a nice vanity address for my token that I call token. Just so I also have something that starts with token, not just the token programs. I hope I did it right. Maybe I should first check if I'm doing this right so I can then also properly create that token. Well, now I'll wait another minute, and if it doesn't match, then if I don't get any matches, then I try Tinder. There we go. Token L. That's my loser token. 230 million attempts it needed. And again, if I wasn't recording, it would probably be faster. Also, your machine might probably be better than mine, so it might be faster for you. Or slower. Who knows? Definitely faster if you're using GPUs. Anyway, what do we do with this seed now? Well, basically the same as we did here. We just need to do a system program create account with seeds before creating the actual token mint. And should we try this also with the new Web3.js? Let's do it. Let's also try this with the new Web3.js just to get used to it. So just to double check, with that authority, the token program as the owner, and that seed, we will get token L. Nice. So that works. But we knew that. Now, instead of just logging this, we want to actually create a token. So send the transaction that creates us that token. For that, we need to figure out how we create tokens with the new Web3.js. Didn't we already do this? We did a transfer checked. We did not do a initialize mint. Well, let's do that then. But we know where those things live. They live in the Solana program token. From here, we import mint. No, not mint. Initialize account. Initialize mint. Decimals, mint authority. We go with 9 decimals as usual. Mint. So this will be my account now. And mint authority will be my authority. Looks like an instruction. Great. But we don't need just this instruction. We also need the create account instruction that we need to perform before that we get from the system program. That's from the system program. We get create account with seeds instruction, which will take amount base account and so on and so on and so on. Okay, so amount. Now I need to know how big a token account is, because I could of course say like 1 million lamperts, but first of all I don't want to overpay, and secondly I want to teach you how to get it done right. So in the token there is a get rand or get size, get mint size. Haha. Oh, this is all, sorry, I'm so used to Rust. Account size is get mint size. 82 bytes seems plausible. So the account size is 82 bytes. So we need 1 million lamperts, approximately 1.4 million lamperts. Let's create that account with rent. The base we said is my authority. Why do you need a base and a base account? What's the difference? So it will now complain about a few things. First of all, the base account and the payer need to be actual key pairs, right? And key pairs in the Web3.js is what? A transaction signer. Okay, so obviously having them just as an address is not enough. I'm gonna do that again. I'm just gonna borrow this from another video on the Web3.js. And import and import and import with the right path. So mint authority, authority address, base authority, authority address, and then this one is fine, and this one is also fine now. Now it doesn't complain anymore. Wonderful. Then the create account instruction and the initialize mint instruction, maybe put them in the right order, and then also put them into a transaction. We create a version transaction. We append 2 instructions, first the create account instruction and then the initialize mint instruction. And we set the fee payer to our authority. Then we set the block hash. Then we sign. Good. And then we send and confirm. Commitment confirmed. We should get a transaction signature. Let's see if we can just create a token with a Vanity address like that. So let's go. No. Invalid instruction data. The system program is already not happy. Why are you not happy? So, I want to sign with a base as well, so I give it as a transaction signer. I have it as the fee payer, so I did sign with it. That's not the issue. Also would get another error. The new account, that's the account that we derived that way. That should also be correct. Can I just push it out for a second? So it failed. I paid. I have this account, system program, and this one failed. Why did it fail? I seem to have the right accounts. No, I don't have the right accounts. Hold on. Account 1 is my signer. Account 2 is token L. So that's the new. And this thing here should be token keg. No, maybe that's fine, because the owner and the seed, it just actually puts in the instruction data. Maybe Solana FM, your favorite block explorer, can tell us more. It doesn't even show the data. Damn it. That's even less helpful. Doesn't show anything here. Yeah, I don't get it. This is one of those things where I'm like, I have no idea why. All right, I'm gonna figure this out. I'm not gonna give up here. Right, let's quickly compare. If I had the BPF loader as a program and the seed from before, then I would get that address. That's the instruction data. That fails. But when we deployed the program, we also called the system program create account with seeds, and that's what it looked like. So system program, NDX, NDS, NDX. So that's all right. That's just my signer, fee payer, and base address. That's fine. Then the seed. Hold on, but here, why does the Explorer decode it differently here? Because I do a system program create account with seed. And here I do a system program unknown instruction. Because I have 3 something, something, something. And here I have, can I have that raw? That's also 3 something, something, something. So clearly something is not so correct here. Let's keep comparing. So we have 3 for the instruction. Okay. Then we have 91 tuck until 1F. 91 until 1F. Okay. That's also the same. Then we have 10 for probably 10 characters. Sorry, it's hex. 16, yeah, 16 of course. So we have 16, it's not 10. It's 1, 2, 3, 4, 8, 16. So that's the 16 characters. Are they also the same? Not, whoa. I think I see it. I think I see what the issue is. I think I found an issue in the new Web3.js, which might by now have been fixed, but in the version that I'm using is not fixed. It's using 4 bytes for indicating the length when it really needs 8 bytes for indicating the length. And the rest should then probably be the same again, yeah? So I just have 4 bytes to view. See, I need to dig pretty deep. And that's the issue with the new Web3.js. It's not battle tested yet, but that's what I'm here for, right? To battle test that shit. Cool. Well, I don't even have the source code for this, but you know what? I'm gonna make myself a quick fix for that, because I can't be bothered to deploy that package myself and do stuff. I'm just gonna add 4 zeros at byte number 32 plus 8, which is 40. At byte 40, I need 4 more zeros. This does need to be nice. It just needs to work. So the first 40 bytes I said. So here the target start is 0. Here the target start is 44. And then I have 4 more bytes of zeros in between, which I don't need to write because the uint8 array should be zeros in the beginning. And then I just need to get that new data somehow into there. It's read-only, damn it. Fixed create account. Just the data, I'm gonna use my new data. There. Fixed it. And now I'm gonna use that fixed account instruction and do the same thing, which will fail, but hopefully for a different reason. Now, see, now it says it's an account with, create account with seeds, and it will fail because that account already exists. Yes, 0x0 account already exists. Boom, because I already deployed a program to this address. Wonderful, but at least now this thing is correct. Damn, I need to write an issue. Okay, being a good boy. Great, moving on. Now that that works, we can get our seed back and do it for the token keg. And that way we should now hopefully be able to create that account and then create a token mint right on top of it. Let's freaking go. Do it. It looks better. Yeah, no error. Wonderful. Look at this. Success. We created token L, which is a token. The token mint, token L. Haha. Nice. Because we just did a create account with seeds, this time with the right parameters. Yes, there's just a bug in the new Web3.js. They're gonna fix it. I made an issue. They're gonna fix it. You will hopefully not have to deal with that. And then we immediately add the token program initialize mint. So now we have this mint. I'm the authority. Pretty nice. And that's how you create a token with a pretty long vanity address. There you go. And that works for your custom tokens and even for pump fund tokens. You can do that. It's a bit more complicated because you will need to call the pump fund program manually, which I've done for a client before. It's not that difficult. So even for pump fund tokens, you can use vanity addresses that are super long with Caveman's nice vanity grinder. Pretty cool. Yeah, I like it. Good. And we're gonna end for today because I'm hot. All that grinding vanity addresses made it pretty hot in here. Or it's the 33 degrees centigrade outside and me living on a top floor without air conditioning. Could be both. But yeah, thank you for coming around and joining me in this endeavor to grind ourselves some nice addresses for programs and tokens. It is fun. And I'm gonna probably just go here and grind myself some more. Let's try 7, but use, what is it? Case insensitive. Maybe I can get my full first name in a token address. The Andreas token. Let's see how long that takes. Meanwhile, I'm recording the outro. Thanks for watching. I mean, if you now really want to grind yourself some nice addresses, you know where to find all that stuff. I'll put the links in the description to Caveman's repository. It's also really not that difficult to then create a token with that address or deploy a program with that address. And even if that's not like functionally anything different, I just really enjoy good vanity addresses. That's why I did all of this, because I just like having cool addresses. You could even use that address for yourself. Hold on, yeah, let's do that as well. So actually, wait. Actually, if I don't let you grind that for the token program, but for the system program, then I can create the account with the system program as the owner, and then it's basically like a wallet address. Except I can't directly sign for that. I will always need to go through the system program, but I can do all the system program things with seeds. I can do transfer with seeds. And then basically I have a wallet that starts with a nice vanity address. We found an address. Look, with that seed, I can get that address at the system program. So I have a vanity address of 7 letters, and it only took a minute to find it. That's pretty cool. Should I show you what I mean? Because here's the thing. Let's pretend that this was my address, right? Cool, I still have 4 sol. So let's say I transfer to this address 1 sol. It's a new address, so yeah, whatever. And now this address exists, right? Now it's a regular wallet that has 1 sol. But I don't have the private key for it. I don't. There is no private key for it. But there might be a private key for it, but I certainly don't have it. But what I do have is the knowledge of this seed. And what I can do now, hopefully, if that's correctly implemented, I derive it again as usual, this time with a system program address, because that's the actual owner. And then I do a get transfer sol with seed instruction, which hopefully is gonna work correctly, which takes the amount, I don't know, even if I just transfer 100, the base account, that's my authority address, the destination, I'll also send it to the authority, why not? I could send it anywhere. Source, that's now the account. From owner, now it must be the system program. Good, you want a big int, okay. And like this, let's see if I can send that. Transfer, nope. Potentially it has the same error as before. Failed because invalid instruction data. Is it once again that you... Once again, it just uses 4 bytes when it probably should use 8. So I should probably add the 4 bytes at byte number 16. So as a quick fix, I'm going to do the same. You will not need to do this. Hopefully it will be fixed by then. But for now, I will need to do this manually real quick. So 16 plus 4 is 20. Then it will work. Haha! I'm a freaking genius. And look at that. it let me do a transfer. It let me do a transfer. I can send out from that address, even though I don't have the private key for it. I still need to sign with someone else. In fact, I need to sign with this very account because this very account is the base for the derivation of this. So I can't just sign with anyone. But if this guy signs, who I used as the base to derive this address, then I now have this account essentially. So basically it's just another way of having a system program account. And this one is slightly safer than this in terms of getting hacked. So it's less likely that this one will get bricked because you would need to brick it with seeds. And hackers don't do that. Unless everybody uses wallets like that. But nobody does. Except for me. And maybe you now. So this is cool. That's the third use case. We can use those vanity addresses for programs, for tokens, or for your own wallets. It's just a bit complicated to transfer stuff out of there. But if you're a dev, you kind of like that. Or maybe that's just me. But that's cool. I have my Andreas wallet that I can transfer stuff out from. Really nice. It's just a system program transfer with seeds with those additional 4 0 bytes here to make it correct. But yeah, it's pretty cool. I like that. And to keep that wallet safe, you will need to keep access to this thing, not lose the private key for that. But even if that thing is compromised, the hacker would still need to know the seed, which if you interacted with the account once, they will know the seed because it's on chain. But if it's a completely clean wallet, like before I did that transaction, nobody, except for me, knew that seed. That's pretty cool. So that's a nice use case for like one-time payment addresses where you have your wallet and you want somebody to pay you. So you give them a new wallet with a nice vanity address. And once they paid you, you move the funds out with this instruction. That's a cool use case that I'm probably going to use this for because I like to just give everybody a new address for everything. That's pretty cool. I like this. This is fun. I'm enjoying this. I hope that you had as much fun in this video as I had. And even if not, I hope that you learned something. I'm going to put the video on the create account with seeds so that you can learn more about that here and some other video that YouTube suggests. Make sure that you like this video if you enjoyed it. Make sure you are subscribed so you get notifications for future videos, or just follow me on Twitter or X. Yeah, make sure that you don't miss my future videos because we do cool stuff. I think we do cool stuff. I might be biased, but I think we do quite some cool stuff here. So yeah, I enjoy this. I'm having fun. I can even tolerate the summer heat when I can grind myself some nice vanity addresses. All right, and with that, I'll see you next time.